The introduction of the Pokémon V-UNION mechanic has given players a lot to think about when they're constructing their decks. In this episode of Pokémath, we're going to take a closer look at what exactly is this V-UNION mechanic, and more importantly, how often do you get to actually play it. Before we dive into some numbers, let's first look at what a Pokémon V-UNION is, as this unique mechanic can be tricky to understand. Each Pokémon V-UNION is 4 separate cards that can be combined into one card. Each of the 4 separate cards have the same name. You can therefore only play a total of 4 Mewtwo V-UNION cards in your deck. If you have all 4 parts of the same Pokémon V-UNION in your discard pile, you can put it into play on your bench, provided you have a free bench spot. The V-UNION Pokémon is treated like a normal Pokémon. For instance, it can only have one Pokémon tool card attached. Also, all 4 parts of a specific Pokémon V-UNION in your deck must be part of the same full illustration. The Pokémon V-UNION cards come with massive HP, several attacks, and sometimes even several abilities. You can still only attack once per turn, but you have many attacks to choose from. Mewtwo V-UNION, for instance, has 310 HP, 4 different attacks, and 1 ability. If Mewtwo V-UNION gets knocked out, your opponent will draw 3 prize cards. Each Pokémon V-UNION can only be put into play once per game. So, if Mewtwo V-UNION gets knocked out, you can't play it from your discard pile again. However, you can play a different V-UNION card, as there's no limit on the total number of Pokémon V-UNION you can put into play during a game. However, you can't play the same more than once. A Pokémon V-UNION is not considered a basic Pokémon, nor an evolution Pokémon. Their stage is V-UNION. When in play, the Pokémon V-UNION is a Pokémon V with a rule box. However, when it's not in play, each card of the V-UNION has its type, Metal for Zacian V-UNION, its card type, Pokémon, and its name. So for instance, you can use a Pokekit supporter card to search for one piece of Zacian V-UNION, as it is a Pokémon in the deck. Likewise, you can discard any 2 cards from your hand to search with an Ultra Ball for a piece of Zacian V-UNION. You can then use Jasmine supporter, for instance, to search for a metal Pokémon in your deck, in this case Zacian for instance. And if you're going second in your first turn, you can search for 5 metal Pokémon in your deck, so 4 pieces of Zacian plus something else for instance. And finally, you can also use Professor Burnett, for instance, where you can search your deck for any 2 cards, because of course the Pokémon V-UNION cards is any 2 cards in your deck, and discard them. However, other characteristics, such as the retreat cost, doesn't exist when not in play. Therefore, cards like Heavy Ball and Level Ball will not be able to search a Pokémon V-UNION. Now that we had a look at V-UNION mechanic, let's dive into some numbers. Let's look at the probability of pricing your Pokémon V-UNION. Because if you price 1 or more of your Pokémon V-UNION cards, you can't play it. Oh no! To calculate the probability of pricing 1 or more of your Pokémon V-UNION, we will use the hypergeometric distribution. See for instance Pokémath episode 1 for a detailed explanation of this distribution. The hypergeometric distribution looks like this. It tells us the probability for X successes in N trials when sampling without replacement. You can think of this as the number of ways to choose X out of M cards. Slowpoke slow. Or translated, Pokémath episode 1 explains this in more detail. Let's make it more user-friendly. X is the amount you priced of a specific card. Cards drawn is the number of prize cards you put down at the start of the game. Deck size is the size of your deck at the start of the game. Number a specific card is the number of copies you have of the card for which you wish to calculate the probability of 1 or more copies being prized at the start of the game. For the remainder of this episode, we will simply write. Now, let's begin calculating. Yay! In this first example, you play 4 pieces of Mewtwo V-UNION in your deck. First, we will calculate the probability of pricing exactly one of the pieces. The formula becomes: we got 4 copies of the card in our deck. We price one of the copies. We have 56 other cards in our deck. We want to draw 5 other cards. We draw from a 60 card deck. And we draw a total of 6 cards. The formula then becomes: we get a probability of 30.52%. We can now calculate the probability of pricing 2, 3, or 4 pieces. For 2 pieces we replaced 1 with a 2 as we priced 2 pieces. We replaced 5 with a 4 as we want to draw 4 other cards. Doing the math gives us a probability of 4.40%. For 3 pieces that is 0.22%. For 4 pieces not 0%, just very, very small. Let's put all together in a little table. We insert the numbers that we calculated into the table. We can now calculate the probability for pricing 0 pieces with the same formula. Or simply calculate 1 minus 0.3052 minus 0.0440 minus 0.0022 minus 0.000, as the sum of all probabilities must be 1. Nice! So you have a probability of 64.85% of not pricing any of the 4 pieces. It is now easy to also calculate the probability of pricing 1 or more pieces. Looking at the table again, we either take the sum of pricing 1, 2, 3, or 4 pieces, or take 1 minus 0.6485, that is, 1 minus the probability of not pricing any pieces. That gives us a probability of pricing 1 or more pieces of 35.15%. Easy! But what if you want to play 2 different Pokémon V-UNION in your deck? Crazy? Maybe. But let's calculate the probabilities of pricing all the different pieces. There are now 8 pieces, so we therefore have a lot more combinations to consider. You could price 1 piece of Mewtwo V-UNION and 2 pieces of Greninja V-UNION, or price 0 pieces of Mewtwo V-UNION and 1 piece of Greninja V-UNION, and so on. We can make the following table with all the possibilities. How does this table work? Each cell refers to the probability of that scenario happening. For example, the cell 1,1 refers to the probability of pricing 1 of each of the 2 Pokémon V-UNION. And the cell 2,3 refers to the probability of pricing 2 of the first Pokémon V-UNION and 3 of the second Pokémon V-UNION. Small probability, but still possible. How do we calculate each of the probabilities? We're going to use the multivariate hypergeometric distribution. For a more detailed explanation, you can watch Pokémath episode 6. The multivariate hypergeometric distribution looks like this. It tells us the probability for x1, x2, until xk successes in n trials when sampling without replacement. Scary. But no need to be scared. For our application, it will simplify to this. It tells us the probability of x1, x2 successes in n trials when sampling without replacement. You can think of it as we now divided the 60 card deck into 3 pieces instead of 2. We got M1 of the first Pokémon V-UNION card in our deck, 4 in our example, and we priced X1 of it from 0 to 4 in our example. We got M2 of the second Pokémon V-UNION card in our deck, 4 in our example, and we priced X2 of it from 0 to 4 in our example. We got n minus m1 minus m2 of other cards in our deck, where we draw 6 minus x1 minus x2 of them, from 0 to 6 in our example. And we got a deck of size n, 60 cards, where we draw a total of n 6 cards from it. Remember that we draw 6 cards because we put 6 prize cards down at the start of the game. Let's fill out the table. This cell corresponds to not pricing any of the Pokémon V-UNION cards in our deck, which could be calculated as. See the formula. It gives us 0.4067. This cell corresponds to pricing one of the first Pokémon V-UNION and none of the second Pokémon V-UNION in our deck, which would be calculated as. See formula. It gives us 0.2077. We can now continue filling out the table like this. Please don't mind changing lines. I got lazy like a slowpoke. Remember, the 0.0000 is not because the probability is exactly 0, it is just smaller than 0.001%. The probabilities in this table represents the probability of that event happening. If you want to know the probability of, for instance, having access to at least one of our Pokémon V-UNION, that is, having 0 pieces prized of at least one of the 2 Pokémon V-UNION, we can sum up all the rows and columns with 0, like this. This will give us a probability of 0.8904, which is 89.04%. In a similar way, we can calculate the probability of having at least one piece of each V-UNION in your prizes. You sum all the rows and columns with one or more Pokémon V-UNION in the prize cards, or calculate 1 minus the probability of having 0 pieces prized of at least one of the 2 Pokémon V-UNION. Either way, we get 0.1096, which is 10.96%. Cool! Some questions still remain. Firstly, how does mulligans affect the probabilities? If you draw an opening hand without any basic Pokémon, you shuffle all the cards back into your deck and draw again. This will mean that the 6 prize cards will also be different each time. Secondly, how does allowing the player to draw one or more prize cards in order to complete the Pokémon V-UNION before it's too late affect the probabilities? We assume that if one of the pieces is prized, then we won't have access to it the entire game, but that's not entirely true. We could assume that you're able to draw one or more prize cards before it's too late. Thirdly, how does cards like Fionia affect the probabilities? Considering the first question, all we have to do is correct the probability you're interested in for mulligans. Say you calculate the probability of having at least one piece of a Pokémon V-UNION in your prizes. We learned earlier that the probability is 35.15% of that happening. 0.3052 plus 0.0440 plus 0.0022 plus 0.000 or 1 minus 0.6485. To correct it for mulligans, we would have to calculate the following. 3515 divided by 1 minus PM, where PM is the probability of having a mulligan. The term 1 minus PM refers to the probability of not getting a mulligan. See Pokémath episode 2 for a more detailed explanation. PM is calculated using, you guessed it, the hypergeometric distribution. This number will of course be different depending on how many basic Pokémon you play in your deck. We will first assume that your deck contains 15 basic Pokémon. We can then calculate the probability for getting a mulligan as. We got 15 basic Pokémon in our deck. We want to draw 0 of them in our opening hand. We have 45 other cards in our deck. we want to draw 7 of them. Our deck consists of 60 cards, and we draw a total of 7 cards. We do the math and get 11.80%. We can now insert that in our previous formula. We then obtain a probability of 39.85% of pricing 1 or more of our Pokémon V-UNION pieces when controlling for mulligans. This means that in about 4 out of 10 games, you don't have all your Pokémon V-UNION pieces available at the start of the game. While this answers the first question, we're still left with 2 questions unanswered. How does allowing the player to draw 1 or more prize cards in order to complete the Pokémon V-UNION before it's too late affect the probabilities? How does cards like V-UNION affect the probabilities? Unfortunately, answering these questions would have to wait for another episode. And like this, we came to the end of this video. Thank you all for watching, and be sure to show your support by liking this video and subscribing to the channel. And I will see you back for our next class here in Stefan's classroom.